In Lesson 2 of Module 1, the students are going to be exploring quadratic functions. Again, not for mastery, but just to take a look at it and understand within the course of algebra that not everything that they're going to graph is going to be a straight line. So there are two instructional outcomes that we're looking at. The first one says to represent graphically a nonlinear, or basically a quadratic relationship between two quantities and interpret the features of the graph. The second instructional outcome is going to be to choose and interpret the scale on a graph to approximately represent an exponential function. Again, the purpose of this video is to provide a resource for both the parent and the student where both can review a lesson at home to improve classroom learning and provide improved homework understanding. So in example 1, in class, the students were given an opportunity to watch a very brief video, and the teacher is asking the student what did they observe in this video. So we'll take a moment, take a look at it. It's very quick. And in that video, what we saw is someone releasing a soccer ball at the top of a peak, rolling down 2 yardsticks and landing onto the ground. And so in class, the teacher is asking students, what did we observe? What did we see happen? And a lot of times the students will say, well, it went down the ramp and then it went straight across the floor. Some students may say that as it's going down the ramp, it's speeding up. And those are just the type of things that we want the students to think about and look at in terms of what's going on. One student may also say that the elevation is decreasing because you notice it is starting above the ground, and as time is passing it is getting closer and closer to the ground until it gets to the ground. So again, at this point, in the class, the students will be writing down any kind of thoughts that they may have, and the teacher is going to help them with that. And so then from there, what's happening is the teacher is asking in small groups for the students to come together and design a graph or a picture very similarly to what was done yesterday in class for lesson 1 of what do they believe the graph will look like. Now again, the video is very short, and while we're not looking for specifically a correct answer of how tall it started, the student can kind of make that determination. The teacher may choose an arbitrary time for the students and consider that time to be roughly at 12 inches or a foot off the ground. And so, in things to consider is should the change in elevation be increasing or decreasing, and should it be at a constant rate? And so initially the students tend to think this type of function or line is going to come down like this, and then they want to go across. And so a lot of times the students in class in their small groups are going to come up with this picture, and then with a little bit of refinement and thought-provoking questions from the teacher, it's going to come up with this idea, the fact that the graph will actually start somewhere approximately around a foot off the ground, come down, and scroll down in more of a curved fashion, and then hit the ground, and then come across this way. Again, the notation or the purpose of this lesson is for the student to realize that not everything in this world comes in a straight line, but come in a quadratic or a more curvature nature in this course. So after this brief example, and the class won't spend a lot of time with this because it really is just an introduction to the idea that not everything is a straight line. And so it'll bring up this new video about an individual which you may recognize from a previous season of America's Got Talent named Mr. Splash. And so what the students are observing this video is Mr. Splash is going to climb the ladder. And you note that the ladder is approximately 30 feet tall, and he jumps into this pool. Now it shows it twice at regular speed. The teacher may stop the video at times and discuss what they think they see. Now in a moment, the video is going to go in half speed. And so right here you can see in this design that the person is right here, and then he's going to jump, and then we're going to observe how that curvature jump is going to be demonstrated, where he goes up, and then you see him start to go a little bit downwards by design, where it goes this way, and you're going to see it start to decrease really, really quickly and into the pool. And the teacher will stop this several times and say, look, right here it is approximately at 30 feet above the ground, and she'll go down again to where he's now approximately 20, and this happens really, really quickly. This video here is currently being played at half speed, and then right there, maybe 5 feet from the ground, very, very short, and then splashes into the ground. And so again, the students are just taking time and they're looking at it to decide what do they think they see. And again, the hope is, or the thought is, that idea of creating that curvature design as it jumps down into the ground, or in other words, just a non-linear thought in that perspective. Again, same thing in example number 3 on page 6 of the student manual. Just says that the table below gives the area of a square with sides of a whole number of lengths. Plot the points in the table on a graph and draw the curve that goes through the points. And so really all that's happening here is the students is looking at this and saying side 0, 0. And so they're placing a point at that location, a side at 1, 1, 2, 4, 3, 9, and then 4, 16. With again that note or that thought that the student is observing that we have the same particular curve that is not straight in that design either. And so then finally, as we're closing out this particular lesson, they gave the same reflection right here, and they're asking the students on the same graph to be able to reflect a curve across the y-axis. And so we're asking students to think about and realize that if I've got a point right here and the distance is this far away, where would that particular curve be on the other side? And students would realize that it would go right there. Likewise, if I've got this distance from here to here, then that same synonymous point would be right there, another point here, and another point there. So then we ask the students by definition, what are we looking at? And this is just simply the graph of a quadratic function. This notion where we curve up in this direction, and on the other side, we curve in this direction. Again, not mastery here, but just an introduction for the student to realize that not all graphs this semester are going to be linear.